Machining of impellers and other rotary bladed parts requires some of the most complex and challenging 5-axis programming efforts. The GibbsCAM 5-axis MultiBlade option was developed to simplify the programming of multi-bladed parts. Creating a new multi-blade operation is the same as creating any other 5-axis operation, by starting a new 5-axis process. Now under calculation types, we've added multi-blade parts. There are 3 main machining patterns: roughing, blade finishing, and hub finishing. Throughout the interface, we make extensive use of industry standard terminology. This makes defining the part and related parameters easy and consistent. Defining the part components necessary to calculate a toolpath are selected in the part definition area. Check surfaces can also be selected to gouge check undefined faces on the model. Consistent with other 5-axis strategies in GibbsCAM, the part components are color-coded for easy identification. The GibbsCAM Feature Manager is supported and often helpful in selecting part components. Once the part geometry has been defined, simply entering the total number of segments allows full control of how many segments are to be machined and in what order, regardless of what section was used to define the geometry. Five-axis tilting is essential when machining complex parts such as impellers. MultiBlade uses dynamic tilting to automatically calculate the best tool orientation at any given toolpath point. Dynamic tilting will use preferred tilt amounts wherever possible, but will use the full defined range of tilt wherever needed to avoid gouging and allow full reach into all areas of the part. Links are fully automatic by default based on the current toolpath strategy and related parameters. The automatic mode can easily be disabled, giving the user complete control over links, clearance areas, and distances. The amount of toolpath edge rolling can be controlled independently at the leading and trailing edges, as well as the amount of extension past the edges. The roughing pattern is used to initially remove material between the blades, accounting for splitters if any exist. Material is removed in layers. Layers can be offset from the hub, shroud, or more commonly morphed between hub and shroud, as this follows the shape of the stock from shroud to hub. Here is what a typical roughing operation of one section on an impeller with splitter would look like. Blade finishing is a point-to-point toolpath method for finishing blades and splitters. For swarf cutting of blades, we use the swarf machining strategy included in our base 5-axis product. As in roughing, the finishing layers can be offset from hub, shroud, or morphed between hub and shroud. There are also several contour options that allow full control of what portion of the blade to cut without having to change your geometry selection. Just select the entire blade, choose your contour preference, and MultiBlade will do the rest. This is what a typical blade finishing operation looks like. Hub finishing cleans up the floor area between two blades, allowing for splitters if they exist. Since it is a single layer finish process, there are no layer controls with hub finishing. It normally uses the same part definition as roughing, so there is no need to reselect any geometry. This hub finishing operation is using a zigzag climb-only method with direct blends at the edges for smooth transitions in and out of the part. New in GibbsCAM 2013, the 5-axis MultiBlade option adds the automated, specialized functions needed to handle your more complex, multi-bladed turbo machinery parts.